Hello and welcome. Welcome back to the course Learning Azure Databricks. In this lecture, my attempt is to give you an assurance that the selections you have made, that is to learn Azure Databricks, is right by end of this video. So if you have made a selection to learn Azure Databricks, you made the best selection. So in order to justify it, I need to go ahead and give you a lot of information that should help you to make your decision justified. So without any further ado, let me get started. So I was referring to this question that why one should learn Azure Databricks. So to answer this question, let's get to the basics and let's get the answer for it. So at the base, you are trying to go ahead and handle data. In real world, data does not come to you as simple as like a table or that of a file. There are various types of data that you will have to come across. So let me go ahead and broadly classify. So if you look at the data, if you are very lucky, you might get all the data structured. But in real world, the data is not that simple. The data won't always come to you in structure. It will be coming to you in the form of unstructured data also. Like in case of structure, you will get to see predominantly like tables, files, which are very easy for you to read, like an employee table or an employee data set in the form of a CSV or a Parquet file. But when it comes to unstructured data, they are very complex, very much hard to identify the pattern. So like images, audios, videos, unstructured data. So there is a third type of data set that actually falls between structured to that of unstructured. As the name is clearly telling you, it is semi-structured data set. That means it's fully not structured or unstructured. So as part of the real world scenarios, you are required to go ahead and face the data that might come to you in the form of structured, semi-structured and unstructured data sets. So keep this as a reference because we will go ahead and use this multiple times throughout our discussion. Now, the point is, what makes data to be called as big data? If you look at the textual definition, I found it is very interesting that the data, when you go ahead and start, collecting, storing, processing, the traditional systems that are required and that are traditional systems that are basically available to handle it, they start to fail. They give up. So there should be some dimensions to measure. So the dimensions, if you look at volume is a dimension. It is all about the scale of your data, velocity at which you receive it, the type of data that you need to go ahead and handle. That is it, the variety. So if you're not getting a clear picture, let me go ahead and get them very clear. That is in terms of volumes, velocity, and variety. So these three dimensions can help you to define your big data. Now, all that of a data engineer is to work with the data, that is big data, find a way to store it, find a way to process it. So to get some meaningful insights from your data, that means if you are given any data set, you need to work with those data sets and you need to get some meaningful insights from that data. So this is a primary responsibility of a data engineer. So if that is a primary responsibility of a data engineer, then the data engineer needs to go ahead and find a way to process it. So if you go ahead and look for processing engines over the internet, and if you look for the top 10, you will see Apache Spark listing this. It's not that it is just listed here. It's been there for the last 10 years and more. That means Apache Spark is dominating the space of big data processing engine. So the point is that if you start to go ahead and look at your data, you are looking at processing the big data, and you see Apache Spark standing top. Apache Spark is favorite for a lot of organizations. A lot of organizations use Apache Spark when it comes to the big data processing. So now, if you go ahead and start looking at the creators are none other than Databricks. So Databricks is the American national company, and the people behind this Databricks are the people who are the original creators of Apache Spark. So here we see that Databricks is a global analytics and artificial intelligence company founded by the original creators of Apache Spark. So this is the connect that I wanted to go ahead and establish, that Apache Spark is a top engine that is used by organizations and Databricks is the company behind it. So what Databricks basically go ahead and offer, it offers managed Spark solutions to the organizations. For Databricks to run, they need a cloud provider. That means they need a scalable system or a solution. And we have public cloud providers, Azure, AWS, GCP, and so on. The list continues to add. So we are using Azure as a cloud provider and making sure we are running our Databricks on top of Azure. Hence, we have this solution as Azure Databricks. So I hope by now you should have convinced that Azure is the cloud provider and the Databricks is the system or the software that is basically giving us the managed Spark solutions. So this is not the only reason, but there are several other reasons. I'm going to go ahead and talk about it. But if we go ahead and talk about it, it's going to make a very lengthy video. So let me go ahead and quickly summarize it, what I am discussing. So I have the data. So in order to store the data, I have to figure out whether it is structured, semi-structured, or unstructured. And then I will have to go ahead and decide what type of compute. So whether it is for Spark when it comes to any type of data set, or Hadoop, or followed by for data warehousing, because traditionally a lot of organizations have their data warehouses following the structured data set. So if you go ahead and summarize this, and if you have understood this, the next step is what exactly we need to go ahead and consider if we need to look for a unified solution. So unified solution now brings us to a definition called data lake. So data lake is all about nothing but a storage which helps you to store any type of data, whether it is structured, semi-structured, unstructured, central storage, which will help you to store your data in its raw native formats. You can use it for your analytics. You don't need to define any schema upfront, and it will be very much up to date, and new data can be added easily. So now data lake is playing the role of a storage solution where you can extend the support for structured, semi-structured, and unstructured data. Now comes very interesting thing is that we could go ahead and add data lake. We could go ahead and add the data warehouse for our structure. So now if we go ahead and combine both the capabilities together, like a data lake and data warehouse, that's how the new age platform has come into picture, which is nothing but data lakehouse platform or lakehouse platform architecture. So the concept that I want to drive from this is that if you have decided to go ahead and get a unified solution for storing all of your data sets for structured, semi-structured, unstructured, and also extend your SQL data warehousing capabilities, Spark capabilities put together as part of your data warehouse, you will end up in data lakehouse platform. And Databricks is the market leader in the space of lakehouse platform. So Databricks is actually the one who I believe that it has brought this concept of lakehouse platform to the industry. So Databricks is the company that I would say is leading this space. So your selection that you have decided to go and use Databricks as a solution, or that if you are trying to build a career on Databricks, is right, because Databricks is the number one company that is able to go and offer the lakehouse platform architecture. So gone are the days when organizations used to go ahead and have separately from different vendors the data warehouses, storage solutions. Now it is a unified solution. So if you look at their documentation, you will get to see the data warehouse capabilities, data lake capabilities are provided at one place. This is the screen snippet that I've taken from Databricks, just to give an assurance that it is a unified solution where you can get capabilities to store your data as part of data lakes and data warehouses, and hence the word lakehouse architecture. Following that, it is very much cloud supported, like you can go ahead and use on top of Azure, you can go ahead and build on top of GCP, you can build on AWS, and it extends the support for your batch data sets, streaming data sets, data science, data warehouse, BI solution, and it is even can be handled for orchestration. So data lakehouse platform is very, very unique, and it is a real need of the industry because it is a one complete platform or one unified solution made available. So because of these features, there is a lot of demand for people who are building their skills around Databricks or Lakehouse platform architecture. The one thing which makes me more attracted towards Databricks is that it is extending the support for open source ecosystem, and they are extending the support for Delta Lake capabilities, Apache Spark, MLflow. Delta Lake is all about storing your data in an open source format and make it available, and MLflow is for building your solutions around machine learning and make it as a one-stop for your model development, model deployment. And Apache Spark, as you all know, that it is a solution that is available for our big data processing. So because of these, features, Databricks has been positioned to be the number one in the space of Lakehouse platform, and every organization, whoever gets associated with Lakehouse platform architectures, they are well known with Databricks. So the decision that you have made to learn Databricks on top of Azure Cloud Platform, I hope by now that should have been justified, and that has been the primary goal of this video. So I hope the selection that you have made for learning Azure Databricks is right, and you should be able to go ahead and build your skills throughout this learning practice, the Azure Databricks. So that's all for this lecture. Thank you for watching. See you in the next lecture.